Generics were first used in Java 5. It is now one of the most powerful features of the Java programming language. Generic programming allows the programmer to create classes, interfaces, and methods that take a parameter specifying the type of data. It allows you to write an algorithm that is not dependent on any specific type of data. Through this course, we will learn about the importance of generic and why we use them in programming. We will also talk about the different types of generic and the use of wildcard characters in generic. And all the concept will be explained with the examples and their implementation. So let's get started right away. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.
Hello everyone, welcome to the course where I'll be talking about generics in Java. Before getting started, let me tell you what all topics I'm going to discuss in this course. So I'll be talking about what is generics, what is the use of generics in Java programming. Going ahead, the different types of generics, that is, you can generalize the class as well as the method and how it can be done, we'll try to see that. Then the type parameters, the bounded and unbounded type parameters, we'll discuss about all that. And then lastly, we'll talk about the wildcards in Java generics. And also, we'll talk about the example, demonstration or implementation using any of the IDE. All the concepts which we'll study like generic class, wildcards in Java generics, there will be an implementation for these topics as well. So let's get started. The next topic is generics in Java. So what is generics in Java? Generics in Java was introduced in Java version 5. This concept specifies the class or methods for different types. For example, if I want to define or use an array list and I want to create an object for it, suppose the object name is A1 equals to new operator and then the constructor of the class array list. Then in this case, this array list A1, that is the object A1, can contain data of any type. May it be integer, may it be boolean, may it be a string, right? But if I want to specifically define it for string data type, suppose, then I can make use of generics. That is, I can make this class array list a generic class. Okay? And then I can create an object of this class which will be for that specific data type. For example, if I have defined for string data type, then if I should be writing array list string A1 equals to new array list. Now this will, okay, here also angular brackets. Now this will create an object A1 for type only string. Okay, so it will be a list of strings. A1 will contain the list of strings, right? And this is the concept of generics in Java. Generics are mainly used for collections where parameter type for the collections are specified, not the base type. Now, what is parameter type here and what is base type here? So this part is referred as your base type. Okay. And this part is referred as your parameter type. Now, it is said that generics are mainly used for collections because for collections, we need to specify the type of data that the object of that particular collection can contain. Okay. And there we'll make use of generics. So while using that, there will be a parameter type and a base type. So base type is an array list. If I'm using suppose stack. So base type is your stack. And what parameter type consists of? That is what kind of data, what type of data this collections are going to contain. That is array list is going to contain suppose string, then string is a parameter type. If suppose the stack is going to contain the data as integer, then integer is a parameter type. Okay, so this is all about your generics, which are used mainly for collections where we can specify a type for the given class or a method and then followed by which the object will be created only for that particular type. And there are base type and parameter type if you talk about collections. So base type is always the array list, stack, these kind of collections, and parameter type is what kind of data it consists of. So I hope this generics in Java is clear to you. Let's talk about use of generics in Java. So why is generics used in Java? There are two reasons behind it. The first one is that it provides type safety. And the second reason is it resolves typecasting. Let us try to first understand what is this type safety. When we say that a given class or a structure is type safe, and then how generics helps us in providing type safety to collections. Right? So we say that arrays are type safe. Now what is the meaning of it? The meaning of it is, suppose I define an array of type string. Okay? Name of the array is S equals to new string. And then the size of the array, suppose 5. Okay? Now here, if I try to add or insert elements into this array string type S, okay, how will I do it? S of 0, that is at 0th index, I'm going to add ABC. Okay? Then at S of 1, I'm going to add PQR, suppose. Correct? There won't be any error. If I try to add at second index 3, will there be any error? Yes, there will be an error. This is fine, but this will throw an error. Why? Because string type array it is. The array S is of type string. We cannot insert any other data type value into the array. So it will throw a compile time error over here. Right? It means what? That arrays are type safe. Whatever type is specified for that particular array, it can only store that type of data. Fine. Now, collections are not type safe. Okay. Collections are not type safe. Why and in which condition? So, suppose I'm using array list. Okay. And array list object, if I create, suppose A1 equals to new array list. Okay. Now, if I want to insert into this array list, so A1 dot, so there is a method called add inside this array list class, which we can use to insert values into the array list. So A1 dot add, and if I add ABC here, it won't throw any error. If I write A1 dot add, and if I write 3 over here, it will still not throw any compile time error. Okay, because it is defined that it is an array list, but what kind of data it consists of, it is not specified anywhere while creating the object, right? So that's the reason it doesn't give any error. It means what? It's not type safe. So to make it type safe, we make use of generics in Java. Okay, so this was all about the first reason why we use generics. That is, without generics, collections doesn't provide type safety. Next reason is that it resolves typecasting. Now, what is typecasting first of all? The example here is that arrays do not require typecasting while accessing the elements of array. Typecasting meaning any explicit type conversion is not required in arrays, but in collections it does require. Let's see how. Suppose again I'll give an example here of string type array S equals to new string and then size is suppose 5. Okay. Now in this I have added at 0th index ABC. Okay. At first index I have added PQR. Now if I want to access it, okay, for example, suppose there is another variable of type string, maybe value. The name of the variable is value, and I want to store this value of S1 into this value. Then how will I do it? Just here I have to write S1. That's it. There is no type conversion required. This is of type string. This is also of type string. So, okay, it can store the value of S of 1 to value. So this is called as no typecasting required. No explicit typecasting is required in case of arrays. But if I talk about collections, so again I'll take an example of array list here. So array list A1 equals to new, this is new array list, and in this if I store A1 dot add PQR, okay, now I want to access this element PQR. Then how can I do it? Suppose I have variable of type string, the variable name is value equals to, and to access the elements, again in the array list there is a method called as get. Okay, so we'll be making use of get method. Okay, so get, now get what? A1 dot get at the 0th index, that is the first value. So only one value as of now I have inserted PQR, so it will be stored at the 0th index itself. So from 0th index I want to fetch the value. If I write like this, it is going to throw a compile time error. Why? Because it requires an explicit typecasting. Because the compiler will not get to know that the data which is stored at this place is of what type, because it was not specified while the object of array list was being created. So what you have to do in this case is that here explicitly you have to write string. Then only this will be converted to string type, and then it will not throw any compile time error. So explicit typecasting is required here. But if you will make use of generics in Java, then this explicit typecasting will not be required. Okay, so this is the second reason why generics is used in Java programming. Now let us see with the help of an example that when we are using generics, then how it is resolving the two issues just we discussed, that is of providing type safety and resolving typecasting. So how the generics use doesn't require explicit typecasting, and it also provides type safety. So that we'll try to see with the help of an example. So I'm going to create here an array list of type string again. So in this case, what I'm going to do is here in the angular bracket, I'm going to specify string, because here I'm making use of a generic class array list, okay, which is specified for type string. And then I'll make an object for this, okay, using new operator, array list constructor. And you can write here string, or you can skip this as well. Okay. So this is now A1 object, which is of type string, meaning it is storing the data of type string, but it is an array list. Okay. This is together array list. Now, if I have to store values into it, I'll be using A1 dot add method. And if I store ABC, then there won't be any error. But if I store A1 dot add some object of integer class, suppose, or maybe that's what it is, an integer. Okay, some object of integer class, then in that case, this is going to throw a error. It will throw a compile time error because it is using a generic class of type string. Okay, so A1 is an object which should store only data which is of type string. So it is going to throw an error. So you can't perform this line now. So this is how the first point is resolved with the help of generic, that is, it provides type safety. Next one, the explicit typecasting is not required using generics. Let's see that now. So if I take a variable named value of type string, and in this I want to store this ABC, then what will I do? Again, there is a get method for that. Okay, so A1 dot get has to be done and specify the index value. So only one element is there, which is the ABC, and it is stored at the 0th index. So 0 is the index here. A1 dot get. Now here I don't need to do any explicit typecasting. In this case, it will not throw any error. It will be compiled correctly. Okay, so this is how the second point is resolved by using generics in Java, that is, no explicit typecasting is required. So this was all about why we use generics in Java. Let's now see what are the different types of generics. So in this, we'll talk about the generic class and generic method. So first, let me talk generic class. So a class, if it is specified with a particular type, then it becomes a generic class. a parameter is added to a class, and this generic class is also called as your template class. Let's try to understand this with the help of an inbuilt generic class example, that is your array list. Okay, so array list, until generics was introduced in Java, it was defined in this way. See how it was defined? So class array list. Okay, then opening of the class. Inside this, there are so many methods. Okay, but I'm going to talk about few. That is the add method. So there was an add method which used to take object type parameter. Okay, and then there was functionality of this object add method. Then there was a get method as well. Okay, so get method has a return type of object, and it used to take the index value as parameter. Okay, then there was functionality of this get method. So you see here, the add method was taking object type parameter. It means if I create an object of array list class and call this add method, I can pass any object here. And in Java, either it's a string, it's an integer, it's a boolean, or it's everything is a object, right? Of type object. Object is a superclass for all the other objects which are there in Java. So it means what? That we can have any kind of object over here, may it be string, integer, to add, right? And similarly, the get method has a return type of object. So after generics was introduced in Java, that is a Java version 1.5 or version 5, whatever you name it, the same class array list was defined in this way. Class array list, and then there was a type parameter specified in the angular bracket. Okay, so this angular bracket consists of a parameter type. That is, the array list, when it is created, should be specified with a type. Okay, and now inside this, the methods, that is this add and get, there were other methods as well. Two I am going to explain to you here. So add method was modified for type T object as a parameter. Okay, so now whatever is specified here, only that type parameter can be passed while calling the method add. Okay, similarly, the other methods were also modified. For example, get. Now it has a return type of T. Okay, and it takes parameter of index. Okay, so capital I here also. So you can see here that now whatever type is specified here in place of T, when we create an object of this array list class, it is only going to take or call the add and get method for only those specified types. Okay, for example, if suppose I am creating an array list of type string. Okay, so in the angular bracket, in place of T, I have specified a string. Okay, A1 equals to new array list and then closing. Now this A1 dot add, if I want to call, then I can call only for string type values, string type parameter. That is, I should write here ABC in this double quote, that is, it's a string. Any other value here will throw an error. Now, when we do this, what happens at the back end is that a different version of this array list class is used by Java compiler. And that version will be class array list. And in place of T in the angular bracket, it will be string. And rest all things will be modified like that. T will be replaced with string. Okay, so this was your inbuilt generic class example, that is your array list. Now, let us try to see how we can have a generic class for the user-defined type. That is, we can have a user-defined generic class. So to do that, this is the syntax which is followed. Class, that is a class, keyword. This should be small c, okay? This should be CLASS, small c, class. The name of the class, any name you can give. But after that, without any space, you have to mention in the angular bracket the type for the class. That is, when you will create an object of this class, it should be of this type. Some type has to specify there. So T represents that. So there are different, this kind of capital letters used. So T here represents type parameter. Okay. Inside this, you can have your different methods and variables. Now, while creating the object of this class, you have to specify the type every time. Okay. So bank account, class name, that is bank account, and then angular bracket, type specified as string. So now savings is an object which is going to store all the data which is of type string, or which is going to deal with the data which is of type string. Okay. Similarly, current is a object of class bank account, but it is of type string, meaning it is going to deal with the data of string type. Fine. You can have here a user defined name as well. For example, bank account, and then in the angular bracket itself, you can have new account. Suppose new account is of type. Okay, whenever account is newly opened, it is of type new account. Okay, so you can have that type as well here. And then account A1 equals to new bank account, and then here it will be again new account, and then round bracket and semicolon. Okay, so you can have here also as a user defined type. Getting it? But make sure again that this should be somewhere a class defined, a type defined already in Java. Like string is already a defined class in Java, right? So if you are specifying a type here, then this should be already a defined class somewhere. Okay, then only you can use it as a type here. But yes, you can make use of it. So this is how we can have a user defined generic class in Java. Now talking about generic methods. So yes, we can have generic methods as well created for different argument types. Okay, how it can be done? The syntax for that is you have to specify all the access specifiers before whatever you want. Suppose public I'm going to specify here. Then after that, you have to specify the type again in the angular bracket. Okay, it represents the return type from the method, but also it should be followed with void. Now you must be thinking, well, how is to return type specified here? So what happens basically is that if you write return statement inside this method, then it will return whatever you have written, like return suppose string or integer value. So it will return that. But if you have not mentioned the return statement, then also it won't throw any error. Why? Because in that case, it will consider this void as a return type. Okay, so these two have to be specified here. Followed by which there should be the method name. Suppose M1 is a method name. Then inside the bracket as a parameter, if you want to pass any parameter, well and good. If no parameter, then also it's fine. Like normal any other method you can specify. But suppose I want to specify a parameter here of type T. Like I'm not specifying any type here as of now, but yes, while using this method, whatever type will be specified here, this method will be called for that type of data. Okay, so specify T here, and then suppose T1 is the name of the parameter, and then the method functionality here. Okay, so this is the syntax which is followed for defining a generic method. Fine. Now let's see an example here. So there's a class, again this will be small c. Okay, so class, name of the class, that is bank account, curly brackets. Inside this there's a method defined, that is your deposit method. Then you can see here the syntax I told you just now, that there should be an angular bracket with type parameter, that is T, and then void should also be there. And then in the parameter, it takes one parameter here. This example, deposit method takes one parameter, that is an array of type T. Okay, so it's an array of type T whose name is money. Okay, now inside this method, you can make use of this T anywhere. Okay, so you can see here in the for loop also I'm making use of it, right? So anywhere in the function, while writing the functionality of this method deposit, you can make use of T. Okay, so here what is being done is that there's a variable E1 of type T. So I'm using for each loop to iterate over the array, one-dimensional array, that is money, and then print each and every value. Okay, so now you can see after this class is closed, method is closed. From the main method, if I try to call this deposit method, as this deposit method will work on any specified type T, right? So see here, there's a money1 array of type integer. So it is having these values. Then there is another array money2 of type double, meaning it is having double type of values. If I call this deposit method here for money1 type of data, that is of integer type, how can I call? So directly I'll write the deposit method without any object because it is a static method. So deposit, and while calling it, I should pass here money1. It will call this deposit method, okay? And then this T will be replaced with type integer because this money1 is of type integer. Okay, so T will be replaced with this and it will successfully call the method body, the implementation of this method. Similarly, for the other part also, I can call this deposit method again for money2 as well. It will work fine, although it is of type double, because this same method will be replaced with T as double because money2 is of type double. Okay, so this is how we make use of generic methods, or we can create a generic method of our own as well. So this was all about the types of generics. Now let us see the generic class implementation demo. That is, I'll be using a IDE to write down the example code for generic class and generic methods. So let's go to the IDE and start typing the code. So here I have already created a class example with the main method inside it. Now here I'll be creating a generic class first. Okay, and then inside the class we'll have a constructor, we'll have a method. Then going ahead in the next part of the demo, I'll also create a generic method. So first let me create a generic class and see how generic class concepts works in Java. So creation of generic class is same as creating class with a minor difference. So class keyword and then the name of the class. Suppose I'm going to give a name here as bank account. Okay. And then in the angular bracket, you have to specify the type. Fine. So this is the syntax for generic class creation. Now inside this, we can have constructors, we can have methods, and all these constructors and methods, they can make use of this type T. Let's see how. Suppose I'm creating a constructor. Okay. Now this constructor should take, suppose it takes parameter. Okay, it's a parameterized constructor. You can have a parameter here of type T. Okay, suppose T1. Right? Now this T1, suppose I initialize it also. This dot T1 is equal to T1. Simple initialization. Now to initialize this dot T1, I should have this variable created also over here. Done. So this is how we'll make use of constructor. Here also you can use this T once specified for the class. Now let's create a method here. So, okay, public void, suppose the method is a display. Okay. Now in this, it is not taking any parameter, but I want to make use of this T1 over here. Like I want to display whatever, this object while creating the object of this class bank account, whatever it is being initialized with, I want to display that. Then I can make use of system.out.println. Okay, and this I can write T1. That's it. So it will just display T1. Okay. So this is the example, a very small example for understanding how we can have a generic class. Okay, now let's make use of these methods and constructor and everything. So to make use of it, first I should create an object, okay, of bank account class. Now, if I don't specify any type here, it is going to throw me an error because bank account class is linked with a type, right? So I should specify a type here. Suppose that type here for first one I'm specifying is string, okay, and B1 is the name of the bank account equals to new bank account. And now we have to pass the parameter here because it's a parameterized constructor which is defined over here, right? Which is having a type T1. So here this T is replaced with what? String. I've specified type string for the class. So here I should pass some string value. If I pass 3, it is going to throw me an error, right? So if I pass here, suppose hello, then there is no error. Okay. Now suppose I want to create a bank account of type integer and name it as B2. New bank account, and then again to pass a parameter here. Right? So now I can pass 4 here because I've specified here the type for T to be integer. Okay. Now let me call these the method display using this B1 and B2. So B1 dot display if I call, and then B2 dot display if I call. B1 dot display should display hello and B2 dot display should display 4. So you can see the same method, that is display method, inside a class is being used for two different types. That is, one is a string and the other one is integer. And that is the power of generics in Java. So if I run this, let's see what's the output. So yeah, I'll just drag this a little bit. Yeah, you can see hello and 4 is the output what we got. Right? So the first display method displayed hello and the second one displayed 4. Right? That's what was value passed from here. So this was example of generic class. Now let us have a generic method as well. So this method was not generic. Okay, although it was using the type here, the type here as T1, but it was not a generic method. Now let's have a generic method here inside this. So I'm going to have public. Now to have a generic method, we should have a return type specified also of type T. That is any type parameter. Okay, so T. And then we should also have void. And then suppose deposit money is the method. Okay. Now it is going to take parameter of type T. Okay. And let's give another name, T2 suppose. Or I'll give a realistic name. So money is what we'll be depositing in the bank account. So money is the variable name of type T. Okay. And then, then we can have the functionality of this method now. Fine. To have the functionality of the method, what I want to do here is, maybe I could just display. Okay, let's have this as an array, making it little bit complex. Okay, so that we can have for each loop used here. For each type T, for maybe the variable name is I, I'm going to iterate over. Okay, I iterate over money. And do what? Display all the values in that array. Okay, system.out.println I. Okay, so you can see I'm making use of this T over here also. Right, so this is your generic method. Now, how it can be called? So, as of now, this I'm going to comment it over here. Okay. And this also I'll comment it because we are not making use of it, right? So let's try to understand just the generic method. Fine. So now I'll be calling this generic method over here. But before that, I should have a parameter defined, which I'm going to pass to this method. So now here what I'll do is first I'll specify of type string. Okay, not string. We can't have money of type string, right? So let's have realistic data. So integer type money 1, suppose I'm going to specify here. Okay. It's an array. So money 1, or let it be short, M1 equals to. And then I'm going to specify the values itself over here, 100, 200, 300. Okay. Next I'm going to have of type double. Okay. M2 equals to, and then specify the values for it, 20.45, 67.45. Okay, it should be dot. And then maybe 30.00. Okay. Now I'll call the methods. The method is deposit money, right? Okay. So the method will be called, suppose on B1 dot deposit money, and then here we have to pass M1. Fine. Now I'll call this B1 dot deposit money again, but here we have to pass M2. Okay. Now, so what will happen with this is that M1 will be called, that is M1 variable will be used here, and deposit money method will be called. Similarly, M2 will be used as a variable here, as a parameter here, and then deposit money method will be called. You can see here, as it is a generic method, it should work for both of the types equally fine, right? It should display the values inside the array. So let's run the code and see what output we are gonna get. So yes, you can see here. Okay, one thing what I'll do is I'll just little bit reframe it so that the display is proper. Okay, and then after this, let's have one more system.out.println. Okay, let's run the code. It was just to represent the output in a single line. Okay. Okay, this should not be ln. Fine, let's run. So yeah, you can see the output here. Deposit money method was called for M1 successfully and also for M2 successfully. Right? Of different types, you can call the methods. And this is the power of generic method in Java programming. So I hope you understood this, how to use generic class and generic method inside a Java programming code. Now let's talk about type parameters for generics in Java. So what is type parameter? So whenever we define a generic method or a generic class, we specify a type there, right? So there are two types when we use generics for collections. One is the base type and other is a parameter type. So base type is, suppose array list I'm using or stack I'm using, queue I'm using. So these are base type, right? The collections. And then what type of data I'm going to store in the array list, what type of data I'm going to store in the stack, queue. If suppose the data is integer, then this integer is a parameter type. Okay. Parameter type can be now bounded as well. So till now, when we used to specify for any given class, suppose class and then the class name is C1, and then we used to specify T here, right? So this was the unbounded type, meaning there was no restriction on what type this can be. It can be of any type, string, integer, boolean, double, whatever, or a user defined type, right? But we can have bounded type parameters as well. And how that can be done? By using extends keyword. Okay. The syntax for that is the class keyword, small c here, class keyword, the name of the class, and then when used to specify type parameter using T, capital letter, after that we should write extends A. Okay. And A will be that restrictive type which we are going to impose on T. Okay. This A can be another class. It can be another interface. Both is fine. Okay. Then normally inside the class, we can have methods and variables like any other generic class. Or you can have, again, the another syntax is class keyword, okay, class name, and then in angular bracket, you have to mention T, that is your type parameter, extends A and B. Two you can mention also. Two type restrictions you can impose for T, where A and B can be classes or interfaces. Okay, but A should be a class and B should be a interface. Fine, which should implement the type for class A and implement the interface B. Extend the class A and implement the interface B. Fine. Now, let's see an example for this bounded types. Like what exactly this T and A stands for and how we can make use of it. So let's see that with the help of example. So class keyword, okay, small c, bank account, the name of the class, then angular bracket, you have to write T, extends number. So number is a inbuilt class in Java, okay, which is a super class for all these type of classes. That is integer, double, float. So all these number representation, whichever classes are, these are the subclasses for this superclass number. So number is a class in Java. Okay, so that's why we are making use of it. So extends number. Now it is confined that this T can be either of these classes only. It cannot be something outside this number class. So for example, string. String is a class in Java which is not a subclass of number class. Okay, so this T type cannot be of string here. Fine. See the example here. So after defining the methods and variables, when we'll try to call these methods and variables and try to create an object of this bank account class, then how it works. So bank account, name of the class, and then here is specified as integer. And then the name of the object, then new keyword and the constructor for it. So you can see here integer is a subclass of number class. So here there won't be any error. It will work fine. No error. But if I create an object of type string, if I try to make this T as string type, then it is going to throw me an error saying that this string doesn't belongs to the class number. So this is your bounded parameter type. We are bounding the parameter for a specific range. Okay, in this example the range was numbers. So we can have only type as numbers, not string or anything else. Okay, so this was the example for bounded type. Now there are certain naming conventions which are also used for type parameters. So till now we have been making use of only the T naming convention, the T capital letter, which represents the type, right? We are using it for representing the type parameter or the parameter type. Similarly, there is, if you want to represent element, then E is there for key, K is the letter used for number, N is a letter used for value, V is a letter used. So this is the naming conventions which we should remember while dealing with generics in Java. So that was all about your type parameters in generics. Now let's check out the demo for bounded type parameter. That is, I'll be using an IDE to demonstrate the example code for using bounded type parameters. So let's go to the IntelliJ IDE. So here I have already created a class example. In that there is a main method. Now to make use of bounded type parameter, we need to have a generic class as well, right? So let's create a class which is going to be a generic class. The name I'm going to give is a bank account. Okay, bank account. Okay, then specify the type here. Now in this type, I'm going to use now bounded type parameter. Before that, let me first define this class. Okay, so here I'm going to have a method public void. Suppose display method is there. Okay, display method. Then it is going to take a parameter of type T, which is a one-dimensional array. Okay, now in this I'm going to use a for each loop. So which is going to be of type I, and then here it will be over T1, right? Now let's print system.out.print, and here I'm going to print what I. Okay, done. So this is the code. Now before calling this code, let me make use of bounded type parameter. So this is the type parameter, right? Or a parameter type T. Now I want to make this parameter type a bounded one. So to do that, we can make use of extends keyword. So here itself in the angular bracket, you should write T space extends and then any class or interface you can write. Okay, suppose I write a class number, meaning I'm going to confine this T only to the type numbers. Okay, if I write T extends string, then I'm going to only specify or confine this type T to be of type string, that's it, and the subclasses of type string. Fine. So right now I'll be taking number. Nothing else will be changed. That's it. You can make use of the two classes and interfaces here after extends, that is number, and you can make use of any other class or interface as well. So runnable is an interface which I'm making use of. If I want to use another class here, suppose I want to use number and string, then it is going to throw you an error. It says that interface is expected here. So this should be a class and the other one should be an interface. Two classes is not permitted because two classes, multiple inheritance is not supported in Java. With the same logic, here you cannot have two classes. Okay, so one should be a class and the other should be a interface. Fine. Then in that case, you have to also implement this runnable interface, not just make use of number class. So that we'll see later, but you can make use of both of these. Okay, now let's see how we can make use of it from the main class. So here, what I'm going to do is, I'll be first creating the object for bank account class. So yeah, I have to specify the type here. So I can specify integer, okay, b1 equals to new bank account, semicolon, that's it. Then b1 dot display can be called. Okay, so to pass the integer array here, I should define it first. So integer, okay, array, maybe the name of the integer is m1 equals to, in the brackets, I'm just going to write the values. Okay, I'll have another integer array as well of type double, m2, so that we can understand the full concept of generic method here with the bounded type. And maybe 20.45, 12.34. Okay, here it will be a comma ending it with semicolon here. Okay, the name should be different, m2. Now here I should pass m1. Next, suppose b1 dot display m2. Okay, okay, provided double. Okay, yeah, so that's what I wanted to tell you people. So let me comment as of now. So normally let's make use of integer type m1. So here, as t extend number, so this integer class belongs to the number class. So if I am passing here the type m1 to be of integer, this is going to work fine, right? So let us now execute the code and see if it's working fine. Okay, I'll just give a space between these and execute it again. So the output is, you can see it's working fine, 100, 200 and 300, right? Now, this object b1 here was of type integer, right? That's the reason this m1 was restricted to integer. Fine. If I would have defined number, then this would not be restrictive. So you can see here, as it is extending both, so I can have, so output for the second part display method is this and first part display method is this one. And both is working fine here, right? So this is how bounded type works. But if I pass string type array here, string type one dimensional array, suppose s1 equals to new, or not new, I'll just define it itself. So hi and hello. Okay, suppose these two are the values, that's it. So in that case, what happened? Okay, here, fine. So now if I pass here in the display method s1, it is going to throw a error because number will not, it is extending just number, not the other type, that is string or any other classes. So the string doesn't belongs to the number class, how the Java packages are defined. So this will throw a error. Rest it will work fine, right? So this was all about the demonstration of bounded parameter type in generics in Java. Let's now talk about wildcards in generics. So in Java generics, what is the use of wildcards and what are they? So wildcard, the symbol used for representing in Java generics is your question mark. So as the name itself says, question mark meaning it's not defined. Nothing is known here. So the same logic applies here when we use with this question mark symbol as a representation of wildcards in Java generics. That is, when the type of the parameter can be anything, then in that place we put question mark. Okay. For example, in this method where you see here, public static void deposit, array list, and then there is a question mark in the angular bracket, and then there is a name of the variable, right? It means what? This array list can be of type anything. Normally, when we use generics in Java, how do we define this method? So we would define it in this way: public, this will be small p here, public static void deposit. Okay. And then if I want the array list to contain string type of data or integer type of data, then in the angular bracket, I would have written integer, right? And then here money. So this method, generic method, specifies what? That this method parameter should be only an array list of type integer. Yeah. Right? But if I don't know that, and I don't want to specify basically that this array list can be of only type integer, it can be of any other type as well, then in that case, we just mark question mark in place of integer here. That's what is this method all about. Right? So it can take any type in this case. Okay. It can be going ahead inside the method, if I want to add or insert in this array list money integer data, then also no error. If I want to insert a string data, then also there won't be any error, because it can be an array list of any type of data. Okay. And this is also called as your unbounded wildcards. So I hope the concept of wildcard is clear here. Now, there are different types of, this wildcards. So unbounded wildcard we saw where there is no restriction on the type of the parameter. Okay. Upper bounded wildcard is where we put a restriction. A range is defined by defining upper range for the parameter type. Okay. The syntax to use that is question mark extends keyword and then whichever class you want to represent as a upper bound. Okay. So in this example, we can see here deposit method again, and then this array list, that is the money array list, should be of type anything which is of type number and of type subclasses of number. Like number is a predefined class in Java which has so many subclasses defined, like integer, double, so on. So if you want this array list to be of any of these type, number as well as its subclasses type, that is integer, double, float, and so on, then we can write question mark symbol extends keyword and number. This class name we can write here, so that this type for the array list is defined not only just for this class, but all the classes which extends this class. Okay, so that's how we define a upper bounded wildcard. So this wildcard is nothing but a upper bounded wildcard because it is attached with the extends keyword and then a class name. Fine. Then there is a lower bounded wildcard as well. Now, what is lower bounded wildcards? In this, we specify a bound, a range, by specifying the lowest level class. Okay. And then the syntax used to represent is question mark symbol, super keyword, and lower bound class. So you can see here array list, question mark symbol, super keyword, and then lower bound value, that is your integer class. Right? Meaning what? Like number is a super class here, right? Inside this, there is an integer class. Maybe integer class is also being extended by some other class or may not be also. Then in that case, this array list will be of type integer as well as one super class of integer, that is your number. Okay. So this is the meaning of lower bounded wildcards. So the other subclasses of integer, if at all it exists, will not be applicable or as a type for this parameter money in this array list. Okay. Suppose let's assume that integer there class has a subclass that is maybe XYZ. Now XYZ type cannot be for the type money. Okay, for this array list. It has to be only the class integer and its one super class, that is in this case number. Fine. So this is the whole logic of using lower bounded wildcards. So upper bounded wildcards was the upper bound, the upper superclass was specified, and then the subclasses. And here the subclass, one of the subclasses is specified, and its immediate superclass will be included in the lower bounded wildcards. So that was all about the wildcards in Java generics. Now let's see the demonstration for the wildcards in Java generics. That is how practically we can make use of wildcards with the help of example and its implementation. We are going to check that. So let's go to the IDE and start typing the code. So here I have already created a class file, okay, with the name of class example, and then main method is also there. So here I am going to talk about user-defined generic classes and user-defined generic methods, right? And there how we can make use of wildcards is what I'm going to discuss. So the example is about vehicles, and which is having two, subclasses, that is your bike and car, and then bike has certain subclasses again. So we'll first define this complete classes hierarchy and then come to use of wildcards and the methods of these classes. Okay. So let's define those classes first here. So I'm going to define a class vehicle, HICLE. Okay. In this class, we'll be having a constructor first. So let's have a constructor for this class, which takes a parameter of string type, the name of the vehicle, and simply we'll be allocating this name is equal to name. Okay. Okay. So we have to define this variable over here, that is string name. Okay. Now let's have a method also to convert it into the string format, because later on to display the result, this is going to be used. Okay. So string to string method. We are overriding this method, which is already there in Java. And we are going to just return name. Okay. So this is the base class which I have created. Now I'm going to create the other classes, the subclasses of it. So the first subclass which I'm going to create is bike. Okay. Which is going to extend vehicle. Fine. Now in this, I'll be having the constructor of bike as well, which will take string name, and then this dot name is equal to name. Okay, we have to specify it here, string name. Fine. Okay, it says that the default constructor is available for this, but we are not going to make use of it. So let's make use of the constructor which is already there. So the error here shows was super, right? So let's insert the super keyword, super name. In place of this, let's make use of this itself. Fine. Now the next class which I'm going to make use of is maybe the car. So I'll just copy paste the same thing and then edit it. Okay, so this is going to be now car, and this will also be car. Okay, done. Now I'm going to create two more subclasses for bike class now. Okay. So after this, I'll just again copy paste the same thing and just edit the names. So it is going to extend now the bike class, and this is going to be maybe bullet. Okay, it's a type of a bike, right? So make use of it, bullet. Done. Another class again I'm going to create here. The subclass of bullet class is maybe, or okay, let it be this much. Let's see if the requirement is there. We'll make more. So one subclass of bike, that is bullet, and two subclasses of vehicle class, that is car and bike, is what I created. Okay. Now let's go to the main class now, and here we'll be defining the generic methods now, where we'll make use of wildcards with lower bound and as well as unbounded wildcards. So for that, let's create. Okay. Yeah. So let's create here public static, void, maybe delete method. So I'm going to delete the bike. So delete bike method, which is going to take list of type. So here now I'm going to specify the type, okay, of the list or the array list basically. So the type here would be question mark extends bike. Okay, so now the bike and its subclasses, and that subclass was bullet, right? So these two will be applicable for these methods. And let's give a name for this, maybe list L1. And from this list, I'm going to delete bike B1. So let's define the method here. So method, I'm going to use the remove method of array list or list class basically. So L1 dot remove B1. Okay, that's it. And then let's just print once so that it's understood what exactly is happening. So println bike removed. Done. Now the next method which I'm going to write here is public static void add bike. Okay. Now this will also take list type. Again, I'm going to make use of wildcards, but with keyword super. So I'm going to specify a base class here, and its super class will be applicable for this method, for this list type basically. So super, and I'm going to write here the base class. What was the name of the base class? Bullet, right? So bullet. Yeah. Okay, let me write bullet here. And the list is L2, comma. The bike to be added can be given as an input as well. Or let it be just add the bike in the given list. That's it. So L2. And then we'll use add method. So L2 dot add. And what it is going to add. So let's create a new object here. Okay, so new bullet, and let's give a name of it so that while printing it makes sense. Classic. Fine. Let's print as well. So system.out.println bike added. Fine. So these are the two methods. You can see I have made use of super and extends both lower wildcard and upper bounded wildcard. Now I'll make use of the generic, like the unbounded wildcard. Okay. So public static void print items. I'm going to print the list which is having the bike details. Okay. So to that, for that I have created a method here. This will take again a list, an array list of type. Anything can be the type, right? I'm not specifying the type name here. Let it be list, the variable name. Okay. And to display this, so let's use a for each loop to display all the things over here. So this should be of type maybe object. Okay, this will be of type object. Okay, I over list, and what it should do, system.out.println, it should print I. Okay, let us annotate it a little. So yeah, done. So you can see the three different methods with three different types of wildcards to be used in Java generics is what I have made use of it over here. Now let us go to the main method and call these methods and see how it works. Okay. So in the main method, what you have to do is create first list. Okay. So list of type vehicle. Okay. V1 is suppose the name equals to new list vehicle, or okay. So in place of list, let's use array list. Okay. array list, and then semicolon. Now, the another list which I'm going to create is list of type bullet. Bullet. And then let this be B1 equals to new array list. Okay. You can mention the type here as well or leave it as well. Like here you can write vehicle. That also is fine. So it will make use of the constructor of that class, whichever is mentioned here as a type. That's the only difference. Now let's call the methods over here. Okay, so I'm going to call add bike method here. And in add bike, I have to pass the list. So I'm going to pass this V1. Okay. Let's call the add bike also for B1. So let's see, it should work for both, right? That's what has been specified here. Add bike works for bullet class as well as its super class. So bullet and vehicle, both it should work, right? Okay. Now, next, I'm going to call the print method. So I'm going to print here V1. Okay. Fine. V1. And also I'm going to print B1. Now let's call the delete bike method, where I'm going to delete from B1, and the bike which I'm going to delete here is. So I have to specify the bike first here. The variable that represents a bike. So string bike 1 is equals to L1 dot get 0. Okay, not L1. 1 second. Okay, yeah. B1. Right? And here it will be B1. Bike 1, not B1. Okay, what's the error? Provided bullet, required type is string. So this will not be string here. This should be bullet. Okay. Now in this, to delete the bikes from the list B1. Okay. So done. Now let's call the print items here as well. So print items, what I'm going to print is B1. Okay. So let's run the code. It should work fine if the wildcards have been used properly. That is, the add bike method should be called for both. So let's see, it is being added, called for both, right? Bike added and bike added. 2 times I've added the bike, right? And twice it is being called. And this is what is being printed inside this add bike method. That is your classic, the bullet name. So that's the reason it's printing that. But the method is being called twice. And as delete method I've called once. So it is being called once. The bike is being removed from the first index. Okay, the first bike which was added was removed from here. That is, we have added the bike V1, right? The object V1, that is the bike V1 in the list. Then B1 we added the next bike in the list, which was of bullet type, and this was a generic type of vehicle type basically. So you can see here, this is how the wildcards works. So this was all about the implementation of demonstration of how to make use of wildcards in Java and under generics in Java. Now let's summarize the video. So in this video, we discussed about what is generics in Java and why is the use of generics there in Java. How is it helpful in programming? Generics is mostly used with collections. So we saw how if generics is used with collections, how it can solve few problems. And then we went ahead and talked about what is generic class, what is generic method, and then what are the different type parameters. All these we understood theoretically as well as we saw the practical implementation of all these topics as well. And lastly, we discussed about the different wildcards in generics, that is your lower bound wildcard, upper bound wildcard, and unbounded wildcards as well, along with its implementation in Java. So I hope you liked the session. Thank you.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.